Well, hello and welcome back to the channel. So this is part 3 of InMoov running MyRobotLab Nixie. So in part 1 we installed MyRobotLab Nixie and we ran InMoov in virtual InMoov mode or the simulation mode. In part 2 we went through some of the gestures that are available in Nixie. So now in part 3 we're going to be hooking up a physical InMoov to MyRobotLab Nixie. So this could just be the head or one hand, and the rest of InMoov can be run in simulation mode. It just depends how you configure Nixie. So we first need to start MyRobotLab Nixie, same way we've been running it before. Now, unlike previously, I've now got a USB cable between the computer and the megas that are in my InMoov. So we now need to configure that. So we hit the gear icon and we can see that the right and left controllers are turned on. To find out what COM port they're using, we'll run in Windows anyway, we can run Device Manager and then click on the COMs and LPT. You can see here I've got COM5 and COM7 are connected to the Megas because my Arduino, because InMoov's running 2 Arduino Megas, but I don't know which is the left or which is the right side. So I'm going to disconnect the right side Arduino Mega. That's just unplugging the USB cable to it. And we can see that the Device Manager has said that there's no only one, so that must be the left side because that's the only one still connected. Now I'm going to connect it back up, the right side back up, and we should see that come back into the Device Manager. There we go, so 5 and 7, so 7 is the right hand side. So now I'm going to go across and configure the, you can either one first, doesn't matter, I'm just going to do the left side controller first. So I know that's COM5, so I'm going to type COM5, so that's in capital letters. And I'll do connect. And the light's gone green and it's replying back with the information that's connected to the Arduino Mega. And you can see all the left hand side's connected to it and a picture of the Mega. So we need to save that for when it starts up again, and we'll know that COM5 is left side Mega. So I'll repeat that again for the right hand side Mega. This is COM7, so we'll just type COM7 in capital letters. Keep the baud rate or the rate at 11,520. Again, connect. We know we've got a good connection because the light's gone green. And it's telling me there's the things that are on the right hand side Mega. And again, we need to save that. So up till now we've just been using 5 volts to run the Arduino Megas. Now we need 6 volts to run the servos. A little bit of a diagram. I'm using the nerve boards, so it's just a matter of connecting them up that way. I have a 200 watt power supply, which is good for about 33 amps at 6 volts, but I think a 300 watt power supply would be better for a full InMoov because there's quite a few servos. Of course, if you're just running the head, you could do that with like a 100 watt power supply or 50 watt. So I'm just going to click on the hand like we did with the virtual InMoov. Now the slider that's for sensors is for the finger sensors. I'm not running finger sensors, so I won't turn that on. Now you can turn the Servos on or off, so if you have a problem with that left hand, you can just turn the Servos off so it won't drive. But because we're calibrating it, I'll need that on. So bring up the gear, we're going to do the left hand, and we'll do the thumb as well. So if we have a look at the controls, the invert is off, so open will be 0 and closed will be 180. And it's on pin 2, which is according to that chart is correct. It comes pre-configured, so unless you make a change to how you have your servos connected, you don't need to worry about that. So we'll bring up the limits, and if we move the slider now, the thumb physically should open and close. The simulator's also doing the same thing. Now I was running manicure before, and I know that my thumb should be 140. I'm going to slide that across to 140. It's a good idea to do both input and output. So now if I put the slider up to 180, the thumb's going to stop at 140. And again, move those sliders down. You can see the thumb stops in a less closed position, I guess. So I'll put that back up at 140. And I'll hit the save button to save that. There you go, save. There is a rest position as well that you can set. So when you tell InMoov rest, it will drive to that position. Or there is a command when you're doing making gestures to go to rest. So that's what that position is. Otherwise it could just go to the 0 limit. So it's just a matter of continuing on with the other fingers and the wrist and all that, and then the other hand. It's the same process. But I just want to focus on the most difficult servos to calibrate, and that's in the shoulder, particularly the bicep. So on the InMoov page, under the bicep, there's an excellent video on how to set up the bicep, and recommended viewing because it's not hard to break 3D printed parts because the servos are quite strong. So it's a good idea to view that video. The principles are the same. It does use the old interface, but you can see it says input map and output map, which is the same as the input and output on the other ones. And it talks about transferring the data into a text document, but you don't need to do that with Nixie. Just the save button in Nixie does the same function. So I can't recommend highly watching that video on how to set up, particularly the bicep, because it's very easy to break the gears. So I'm just going to run through one shoulder. So select the left arm, left omniplate. So it does already come predefined with the standard limits, but mine is slightly different, as I think everyone's would be. It just depends how the potentiometers are set. again, inverter's off. So if you carefully drive the combo plate up, you want to do all this very easily, very smoothly, so you're not putting too much stress or strain on the 3D printed parts, especially when you get into the limits. You can see that the rest position here is a little bit above 0. That's because it's not in the normal position. It's not at 0. Now we're going to do the shoulder. And again, you can see that the rest position is at, I think that's 30%. So again, you need to do this. If you're not sure on the limits, you want to do this very carefully so you don't overextend it. You can see here that the rest position is actually arm straight down, and then we can drive the arm a little bit further back. And you also notice that the simulation or the virtual InMoov is doing the same thing. There's a good example of the rest position. The arm rotating, but the actual rest position is in its mid position basically. You can see here that the 0 point's been shifted up to 40. Now the bicep, so this is the trickiest servo to set. And this video is very, very helpful. So my biceps are a little bit different than the default, so I'm adjusting that to how they were previously in Manicore. And the first time you drive in this servo, you have to be very careful. It's not hard to break something. So I've saved that because I've made a change. So now we're just going to talk about the NeoPixels. So in the InMoov site, there's a reference to connecting the NeoPixels up. Previously I had connected the NeoPixels this way, so that the Arduino Nano that I was using was acting as a slave. So it was sent through the RxTX command. But in Nixie I couldn't get that to work at all. I'm not sure if that was a problem of me or an issue with Nixie. So luckily the other way of doing it is to plug the Nano in that I was using, or the Uno, straight into the USB hub that's in InMoov, and setting the controller to drive it. So you put the code in there, and the MRL com, download that into the Nano. You've got to do that either way, whether it's the slave or this version. So first, because I'm using it as a controller,
starting controller 3.
First configure the controller the same way I did with the device manager. And in my case, I think it was COM4. Connect is okay. and it detected that it's an Arduino Nano that's running the NeoPixel ring. So I save that configuration. If you don't save it, you won't remember it. So now we can turn the NeoPixels on. So there's my stomach NeoPixels.
Starting NeoPixel.
And straight out the box it started up okay. So we can go in there and configure it. It's just got, I'm not sure how it's working because it doesn't know the controller, so I've connected to controller number 3. And it's on, the NeoPixels on pin 2 of that controller, of that Nano. Save that configuration, and now we'll just run through. I'm just proving that there's a connection by changing a couple of the patterns. So that's communicating okay. So you can call these patterns when you make a gesture in the Python script. By default, I think it's always on Iron Man. Again, we'll save that. Now we'll talk about the PIR and the ultrasonics. So the PIR is passive infrared. So again, we can get the information on the InMoov site. So that's the white dot in the center of the chest there, in the black section. And a bit of information on how to set it up. It is slightly different because that's the old version, the Manicore version, not the Nixie version. So if we hit that icon, we can get us to the PIR.
Starting motion sensor.
So now we can turn the PIR on, the Servos on. So mine is connected to the right side, D23, but you can connect it to the left side. So we save that. You can see that it's flashing red and green now when you move your hand in front of the PIR. And on the text screen there, you can see that it says PIR on or off. So that's used in a couple of the gestures, like I think rock, paper, scissors. So now we'll do the ultrasonics. So that's information sitting there. I have 2 ultrasonics installed, but Manicore only could run 1. I'm not sure if Nixie can run 2. I'm struggling to find out, think of a reason why you need 2 ultrasonics, apart from aesthetics, that it looks better that there's 2. So I've got the ultrasonic right service turned on. So the echo pins and the trigger pin. So it sends out a pulse and then waits for the pulse to come back. So they're as they should be in the documentation. I tried to attach it here, but I'd forgotten to connect the controller up first. So I'm using the right side controller and attached it, so now it's okay. So try that out. I'll just send a ping, and there's nothing in the way, so it's just gone to maximum distance. I'm just reaching across now to put my hand in front of the sensor, and you can see on the text screen there that the PIR is going on and off as well because my hand's near it. So I'll move my hand, and every time I do a ping the distance is changing, so that proves that the ultrasonic's working. I saved that as well.
Starting opening.
So I have a Xbox Connect that was working in Manicore, but when you go there, because I've got a new computer running Nixie, I have to install the Windows software for the Xbox. So I haven't done that yet, so there's no problem, no point having the Xbox Connect running. It's just gone off the blank screen, so go back to IO1.
Stopping
I'm not going to
opening.
run the OpenNI, which is the Xbox Connect, until I install the software on the laptop. Now if we click InMoov itself, there's a configuration file that has all the services that are running. Now, so I've started the NeoPixel and controller 3 and PIR and the Ultrasonics. So when Nixie starts up, it won't run these services. I'm not sure how to make it run the services straight off. But as a short-term fix, I'm just making sure that the services are on. And I'm going to save that as the default configuration.
Stopping simulator.
I'm also turning off the simulator because I don't need that with a physical InMoov running. But you can leave that on. I'm just a bit worried about it putting too much strain on the laptop because it's not got a big processor in it. So I'm going to save the configuration, and I'm just going to save it as the default. So when Nixie restarts again, I just need to go to this screen and hit the start button, and it will run those services. I have a camera in one of InMoov's eyes, so this is the OpenCV settings. So by default that's running. If you don't have a camera, you can turn that service off. Again, that will save a bit of processing power. The camera is on index 0. So it's a USB camera that's plugged into the USB port. And it sees it as service 0 for some reason. So here we go, we start the capture, and so that's a live image. The lens on the eye is pretty foggy for some reason, so it's not a super clear image. But you can see the frame rates and all that there that was ticking over. Well, that's about it for now. So everything else is just a matter of going through and investigating yourself to see what InMoov can and can't do. So until next time, thank you for watching.